Hello, my dears. Today we will be talking about catalysts and also phase changes. I am on page 5 of your notes packet. A catalyst is usually a protein or any substance that lowers the activation energy of a reaction. So by lowering the activation energy, it causes the reaction to speed up. So to really understand what a catalyst is, you have to remind yourself of what is activation energy. Activation energy is the minimum amount of energy required to get the reaction going. Okay, so the reactants have to overcome this energy barrier to get the reaction going, and that's called the activation energy. Now, what a catalyst does is it comes in and it lowers this activation energy. So if you look at this diagram here, okay, this top bolded curve, that is an uncatalyzed pathway. So basically, this is without a catalyst. If you notice here, this is energy. Okay, so this takes longer and more energy to get started. Okay, so that's like right here. So to help you guys see this, I'm just going to put a number as a reference. So let's say this uncatalyzed pathway is 50 kilojoules. Okay, but if you notice here, the dotted line, this is with a catalyst. So this is less energy. Let's say this is like 30. Okay, so basically a catalyst makes it so that the reaction can get going with less energy needed. Okay, so if you think about it, this is there's a protein in your mouth called amylase. Amylase is an enzyme, and if you remember from biology, enzymes are catalysts. And what amylase does is it helps your body start digesting starches and carbs before they even get to your stomach. So by the time they get to your stomach, they're partially digested, and your body has to do less work to really get those starches digested and therefore into your bloodstream. That's energy for you to use. So very good chemicals for us. Without a catalyst, something that could take years to happen could take maybe a few minutes or a few seconds. So they are very beneficial to the energy scheme of things. One important thing I really want to emphasize is that the catalyst does not change the heat of the reaction. So if you look at this here, this is our heat of the reaction. If you notice, the amount of energy required to start and stop the reaction is the same. The only thing that changes is the activation energy. So that's this. Okay, so here, this reaction had to overcome this hurdle. Okay, so that was the activation energy without the catalyst. And then now, okay, now the activation energy is from here to here. Okay, so again, to get delta H, this was in our last video, you'll have to do the heat of the products or the energy of the products minus the energy of the reactants. So none of that changes here. Okay, if this is if the heat of the products, let's say this is, let's say this is 20, and then the heat of the reactants is 5. Okay, well, 20 minus 5 is still 15. That doesn't change from the catalyst, okay? So again, a catalyst simply lowers the activation energy without affecting the heat of the overall reaction or the energy of the overall reaction. Okay, so moving into phase changes. A phase change does not alter the makeup of the substance itself. So we talked about this in the beginning of the year when we discussed physical versus chemical changes. So it's very important to emphasize that a phase change is a physical change. Okay? in a physical change, you are not altering the physical makeup of that substance. The only thing that is changing is the state of matter is changing. Okay, remember the major states of matter we discuss in chemistry are solid, liquid, and gas. Okay, so what happens is there's a transfer of heat into or out of the system. We talked about this in our first video, Intro to Thermodynamics. We discussed the system and the surroundings. Okay, so if heat is entering or exiting the system, this causes a phase change. Okay, there are specific names for each changes in phase. This you guys don't have in your notes, but it's a nice diagram just to kind of help you visualize what's going on in terms of the enthalpy change, so delta H. But what you have in your notes is this table here on the right. And you guys know all of this already, but maybe now you can look at it in terms of enthalpy. Okay, so liquid to solid, that is freezing. Okay, you have liquid water, now it's ice cube, that's freezing. Solid to liquid is melting. Liquid to gas is evaporating or boiling, it's the same thing. Gas to liquid is condensation. These bottom two, you might not remember them or have heard of them, but solid to gas is something called sublimation or to sublime. This is more rare, but it does happen. We saw this with our dry ice. If you remember the day we played with dry ice, we had the dry ice is a solid piece of carbon dioxide, and all the gas that you saw coming off of it was the gaseous carbon dioxide. So that is sublimation. Deposition is a little bit more rare. It's a gas to a solid. And keep in mind, these are all physical changes. So when you have freezing, these are going to be indicated by negative delta H, which is exothermic. So that means that the heat is exiting the system, which is why it will freeze. Okay. Same thing with gas to liquid. That's condensation. So heat is leaving the system. So the gas molecules, you have to remember, gas molecules are really spread out. Okay. And that's because there's more heat involved. You can't have low heat and gases, everywhere. With a gas, if you have a lot of energy, they're going to be more spread out. But the moment you take away that energy or you release that energy, they're going to start to come together. And when they come together, they kind of form droplets amongst each other. And that's called condensation. Okay? Same thing with deposition. We have heat leaving the system. Okay? On the contrary, an endothermic change would be melting. Okay, so when you have a solid going to a liquid, heat is entering the system. So if you have an ice cube and heat is entering in that ice cube, it will melt and become a liquid. So that is endothermic. Liquid to gas, same thing. You have heat entering the system. So a liquid, it's just like when you boil liquid water, it becomes steam. And same thing with sublimation. Okay, so again, back to our dry ice example, we had that solid piece of dry ice, heat was entering the system, and then you guys saw the little gases just coming off of the dry ice. Okay, this should be review, but now you have it in terms of, endo and exo.